Okay, welcome back, and now we're going to start with height of a missile, right? So now we're going to talk about figuring out the height of a missile. So again, I'm going to read it carefully to you, so just make sure you're paying attention, take notes. It says a missile is launched at an angle of 26.55 degrees with respect to the horizontal. Okay, so that means right away, with respect to the horizontal, let's say this is the horizontal. So the rocket is blasting off this way, right? So the angle, so this is an angle of elevation. So 26.55, so that means this angle here is 26.55 degrees. Okay? And so the rocket is going this way. So again, we create another right triangle. And it says, if it travels in a straight line over level terrain for 2 minutes, and its average speed is 6,355 kilometers per hour, what is its altitude at that time? Okay, so in this case, we're saying that the rocket is in the air for 2 minutes, right? So this is 2 minutes after launch, and the average speed of the rocket over those 2 minutes is 6,355 kilometers per hour. Okay, and they want to know what is the altitude of the rocket at that time. Okay, well, first of all, they give us the time and the velocity of the rocket. And they want to know the altitude of the rocket, so that's going to be this value here, we'll call it h. So the height of the rocket above the ground. And we're assuming that it's just traveling in a straight line. And we've got that angle of launch. And so we need to figure out the distance that it's traveled, right? So they want a distance here. Well, we need to find this distance, right? Well, they're giving us the information to be able to find that. So we can use what? We can use the distance equals rate times time formula, where v, the velocity of the rocket, is the same as rate, right? Now, the one thing you have to understand is this is given to you in minutes. The velocity or the rate of the rocket is given to you in hours. So we need to change the time to hours, okay? Because we want the kilometers, right? We need kilometers, so we want to match hours. So 2 minutes, right, is the same as how many hours? Well, in this case, it's going to be 2 minutes out of 60, right? So it's going to be 2/60ths of an hour, or 1/30th of an hour. So that's what we're going to use. So now we can plug this into our distance equals rate times time. And so we get 6,355 times 1/30th. And so when we do that, we get approximately 211.8 kilometers. So this is going to be 211.8 kilometers. That's going to be this, 211.8 kilometers. And now we can use what we know about right triangles to find h. So again, we've got the angle, we've got h, and we've got this hypotenuse. So this is opposite and the hypotenuse, so we're going to use sine, right? So we're going to use sine of 26 0.55 degrees is equal to opposite over hypotenuse, which is 211.8. And so now the height is going to be what? It's going to be 211.8. So this is very similar to the waterfall one. So 211.8 times sine of 26.55. Okay, so now if we take the sine of 26.55 degrees and we multiply that by 211.8, we will get approximately 94.67 kilometers. 94.67 kilometers. So we got the height of the rocket after 2 minutes is approximately 94.67 kilometers. And that's it. See you next time.